Hello everyone, this is Bhumika Mohan. In this video, I'm going to talk about specifying constraints as assertions and actions as triggers in database management system. The contents of this video are: first, I'm going to talk about introduction, then specifying general constraints as assertions in SQL and its examples, specifying actions as triggers in SQL and its examples. So coming to introduction, in the context of database management systems, that is DBMS, constraints and triggers play vital roles in maintaining the integrity and consistency of the data. There are two additional features of SQL, that is the create assertion statement and the create trigger statement. Create assertion statement is used to specify additional types of constraints that are outside the scope of the built-in relational model constraints, that is primary and unique keys, entity integrity, and differential integrity. These built-in constraints can be specified within the create table statement of SQL. Create trigger is used to specify automatic actions that the database system will perform when certain events and conditions occur. This type of functionality is generally referred to as active databases. Coming to specifying general constraints as assertions in SQL, constraints are rules enforced on data columns to ensure the validity and integrity of the data. Common types of constraints include not null, that is, ensures that a column cannot have a null value. The second one is unique, that ensures that all values in a column are unique. Third one is primary key, which uniquely identifies each record in a table. Then comes the foreign key, which ensures the referential integrity of the data in one table to match values in another table. Lastly, it is check, which ensures that all values in a column satisfy a specific condition. Assertions are a type of constraint used to enforce a condition on the entire database rather than on individual tables. They are defined using SQL statements and checked whenever an update or insert operation is performed that might violate the assertion. In SQL, users can specify general constraints via declarative assertions using the create assertions statement of the DDL. Each assertion is given a constraint name and is specified via a condition similar to the where clause of an SQL query. For example, to specify the constraint that the salary of an employee must not be greater than the salary of the manager of the department that the employee works for in SQL, we can write the following assertion. Create assertion salary constraint. Check not exists. Select from employee E, employee M, department D, where E salary is greater than M salary and ED number equals DD number and D manager SSN equals MSSN. The constraint named salary constraint is followed by the keyword check, which is followed by a condition in parentheses that must hold true on every database state or for the assertion to be satisfied. The constraint name can be used later to refer to the constraint or to modify or drop it. The DBMS is responsible for ensuring that the condition is not violated. Any where clause condition can be used, but many constraints can be specified using the exist and not exist style of SQL conditions. Whenever some tuples in the database cause the condition of an assertion statement to evaluate to false, the constraint is violated. The constraint is satisfied by a database state if no combination of tuples in the database state violates the constraint. The basic technique for writing such assertions is to specify a query that selects any tuples that violate the desired condition. By including this query inside a not exist clause, the assertion will specify that the result of this query must be empty so that the condition will always be true. Thus, the assertion is violated if the result of the query is not empty. In the preceding example, the query selects all employees whose salaries are greater than the salary of the manager of the department. If the result of the query is not empty, the assertion is violated. Coming to another example, let's see. Suppose we have a database for a retail store and we want to ensure that the total number of products ordered does not exceed the available stock. So here comes the create assertion check stock, then check not exists, select product ID from orders O products P, where O product ID equals P product ID. Group by O product ID having some O order quantity greater than P stock quantity. Coming to specifying actions as triggers in SQL, triggers are procedures that automatically execute in response to certain events on a particular table or view in a database. Triggers can be invoked before or after an insert, update, or delete operation. Another important statement in SQL is create trigger. In many cases, it is convenient to specify the type of action to be taken when certain events occur and when certain conditions are satisfied. For example, it may be useful to specify a condition that, if violated, causes some user to be informed of the violation. A manager may want to be informed if an employee's travel expenses exceed a certain limit by receiving a message whenever this occurs. The action that the DBMS must take in this case is to send an appropriate message to that user. The condition is thus used to monitor the database. Other actions may be specified, such as executing a specific stored procedure or triggering other updates. The create trigger statement is used to implement such actions in SQL. Coming to example of this, consider the same retail store database. We want to automatically update the stock quantity in the products table whenever a new order is placed in the orders table. So coming to creating a trigger, create a trigger. Here, create trigger update stock as used, and after that, after insert on orders, for each row begin, update products, set stock quantity equals stock quantity minus new order quantity, where product ID equals new product ID and is used to end this program. Trigger explanation. After insert on orders, specifies that the trigger will be executed after an insert operation on the orders table. For each row indicates that the trigger will be executed once for each row affected by the insert operation. Begin to end, the block where the trigger's SQL statements are defined. Coming to trigger action, when the new order is inserted into the orders table, this trigger will automatically reduce the stock quantity in the products table by the quantity ordered, that is new order quantity, for the corresponding product ID, that is new product ID. Triggers can be used in various applications such as maintaining database consistency, monitoring database updates, and updating derived data automatically. So, summary of this video is constraints as assertions. Assertions can be used to enforce conditions across the entire database. They are powerful but are not supported by all DBMS. Coming to actions as triggers, triggers automatically execute specified actions in response to certain events. For example, insert, update, delete operations on a table. They help maintain data integrity and consistency by automating processes such as updating related tables. So, coming to conclusion, by using assertions and triggers, we can ensure that our database enforces complex integrity constraints and automatically handles specified actions, thereby maintaining the integrity and consistency of our data. Thank you.